Hi, my name is Anthony Espinosa, and today I'm going to be teaching you how Gaurd cells regulate stomata. So let's begin. So what are stomata? Well, stomata are pores mostly found on the underside of leaves in the leaf epidermis layer. They are also found along the stem and in petals of the flower. There are up to 1,000 stomata per square millimeter in some leaves, constituting up to 3% of the total surface area of the shoot. So here's the function of the stomata. The stomata regulate gas exchange and control water loss. They help the plant balance its need to retain water with its need to obtain CO2 for photosynthesis. Also, they release oxygen into the atmosphere. So what are Gaurd cells? But before you find this out, let's take a short quiz first. Question number 1. On which region of the plant are stomata mostly found? Is it A, the petals of a flower, B, along the stem, C, in the epidermis on the underside of the leaf, or D, in the root? If your answer is C, then you are correct. Stomata are mostly concentrated in the epidermis layer of the underside of the leaf. Now let's move on to question number 2. What is the function of stomata? Is it A, control water loss, B, release O2, C, regulate gas exchange, or D, all of the above? If your answer is D, all of the above, then you're correct. The stomata perform all three of these functions. Now let's go back to the question, what are Gaurd cells? Well, Gaurd cells are specialized paired epidermal cells that surround a stoma. They control the opening and closing of each stoma. When stomata pores are open, carbon dioxide can enter the leaf by diffusion, but consequently, water vapor diffuses out of the leaf at the same time. Closed stomata prevent water loss, but also exclude carbon dioxide from the leaf. So now let's find out how Gaurd cells function. Here's a step-by-step diagram of their function. In the light, Gaurd cells actively pump protons out, thus facilitating the entry of potassium and chlorine. Higher internal potassium and chlorine concentrations give Gaurd cells a more negative water potential, causing them to take up water. The resulting increase in turgor pressure stretches the cells and opens the stoma. In the absence of light, potassium and chlorine diffuse passively out of the Gaurd cells, and water follows by osmosis. The Gaurd cells shrink and the stoma close. So you've reached the end of my presentation, but first let's take another short quiz. Question number 1. Gaurd cells are specialized epidermal cells surrounding a stoma that control the stoma to blank or blank. The answer is open or close. Question number 2. True or false? In the light, turgidity in Gaurd cells is caused by the accumulation of potassium and chlorine ions, causing the stomata to close. The answer is false. This causes the stomata to open, not close. Question number 3. True or false? In absence of light, potassium and chlorine ions, along with water, diffuse out of the Gaurd cells, causing the stomata to become flaccid or loose and close. The answer to this question is true. So you have reached the end of my presentation. My name is Anthony Espinosa, and it was my pleasure to teaching you how Gaurd cells regulate stomata. Thank you.